Greetings everyone. In the previous video we looked at how to program the low fuse byte of the ATmega16A microcontroller. We configured it so that it can use the 8 MHz external crystal oscillator. So with that done, now in this video we are going to see how to use one of the pins of the microcontroller as output. So in order to look at what pins can be configured as output, you open the data sheet and click on pin configurations. This is the microcontroller that I am using, 40 pin PDIP plastic dual inline package. So if you see, it has pins labeled PA0 to PA7. All these pins constitute, these 8 pins constitute port A, and here you have pins PB0 to PB7. These 8 pins constitute port B, and similarly you have port C over here and port D over here. The microcontroller that we are using, ATmega16A, has 4 ports: port A, port B, port C and port D. Each port has 8 pins. You are free to choose any pin you want as an output. You can configure it as an output, you can configure it also as an input, right? So the thing that you are going to do is called GPIO, general purpose input output. So we will take one or more ports or one or more pins, and we will configure a few pins as output and a few pins as input. Now in this video what I am going to do is I am going to choose, let's say, PB0. You can choose any pin you want, you are free to do that. I am going to choose PB0. I am going to configure this pin as output, and then I am going to connect a resistor and an LED in series with this pin, PB0 pin. And then what I am going to do is I am going to turn on the LED for 1 second and then turn it off for 1 second. This is going to repeat forever. So this is called blinking LED, and this is the embedded version of the Hello World program. In C, the first program that you write is called as Hello World. Similarly, in embedded, the first program that you are going to write is going to be blinking an LED. This is your microcontroller saying hello to you and everyone else in the world, right? So that's what we are going to do now. And in order to understand how to program this microcontroller to use any one pin of any port as output, you will have to click over here, IO ports, and we will go to the register description. Right now we are not going to use this register, special function IO register. This will be used to disable pull-ups. We are not going to bother with that now. The registers we are going to focus on are the data register, port A, port B, port C and port D, data registers, and then the data direction registers. We are not going to be bothering about the pin register now, right? This we will use when you are going to use any pin as input. Now we are going to be using a pin as output only, so we are not going to use this one. And the port we are going to be using is port B. I have chosen it, you can use anything you want. So the registers that I am going to be interested in are the port B data register, which is labeled port B, and the port B data direction register, which is labeled DDRB. These are the two registers that I am going to be interested in. I told you that I am going to connect a resistor and an LED in series with PB0, the 0th pin of port B. So I have to focus on this bit over here, port B0 and DDB0. The procedure is, the job of the data direction register is to control whether the port is going to be used as an input or an output. Input means data will flow from the pin to the microcontroller. Output means data is going to go from the microcontroller to the pin. Okay. So if you want to configure PB0 as output, you need to write a 1 to this value, DDB0, this value over here. You need to write a 1 to it. If you write a 1 to it, PB0 will be configured as output. Once you have done that, if you want to make PB0 logic high, then you need to write a 1 to port B0. If you want to make PB0 logic low, then you need to write a 0 to port B0. So this is what we are going to be doing now. Okay, we are going to configure the PB0 pin as output by writing a 1 to DDB0, and then we are going to write 1 to port B0 in order to turn on the LED, and after a short delay we will be writing a 0 to port B0 in order to turn off the LED. Right, it's very simple. The first program that we are going to write is blinking an LED connected to PB0. It's a very simple program. You need to know only these two, port B and DDRB. Now before we proceed any further, it is important to have the toolchain installed. You can do it from the command line if you want, but the easiest way would be to use the package manager available in your Linux distribution. Since I am in Ubuntu, I will be using the Synaptic package manager. You can open your package manager and then search for AVR. I have already searched for AVR, and this is what I have got. I have installed all this already. I will tell you what you need to install. In the previous video itself, I would have told you how to install AVRDUDE. Now the applications that we need, or the packages that we need, are these things. avr-libc. This is a standard C library for your AVR development. Okay, it contains a set of library functions which you can use to program your microcontroller. So you need to install avr-libc, and then these two, gcc avr, gdb avr. Actually we are not going to use gdb avr right now, but gcc avr is very important. This is the compiler. So the libc contains a set of library functions. You need to install that, followed by gcc avr. This is the compiler, and then there is also a simulator that you need to install. That is this one, simulide. The simulide actually uses the simul-avr, but once you install this, this will be a dependency and it will also get installed. So simulide. So these are the things you need to install. So I will tell you one more time what you need to install. You need to install avr-libc, and then gcc avr, and then a simulator simulide. So once you have installed these, you are ready to start programming. So I have already installed all the software that we need. So now what I am going to do is, I am going to open simulide and I am going to draw a schematic. Here it is. So I will click on it and it has opened. This is a very nice software and also very simple to use software. So I will save it first of all. I will choose a folder. I will create a new folder over here, right? I'm going to name the folder as blink LED. Okay, this is where I'm going to save all the files related to this project. Okay, so I'll click on save. Now I need a microcontroller, so I will scroll down, and then here you have PIC and AVR microcontrollers. I am using the avr-ATmega16A microcontroller. So ATmega16 is available here. I'll just have to click and drag it over here, right? By scrolling you can zoom in or zoom out. Okay, so this is my microcontroller, and I am going to connect a resistor and a LED to PB0. So I will search for resistor and LED. I have a resistor over here. I will click and drag. It's 100 ohms, but you can change it. I'm going to make it 330 ohms. That's the actual resistance I'm going to connect. And then you need an LED. So here it is. I'll click and drag. I'll rotate it. Now what I need are power and ground. So ground is over here. I'll click and drag, and for power I will use this fixed voltage. This will give you 5 volt fixed voltage source, so I will use it. I'll place it over here. Now we are ready to connect everything. So the ground pin I'm going to connect to this, and VCC I'm going to connect to this thing over here. I will add 2 more grounds for this LED and this ground pin over here. Port B0 I'm going to connect to the resistance, and then this I'm going to connect to the anode of the LED. The cathode of the LED I'm going to connect to ground. I have connected it in such a way that whenever B0 becomes high, LED will turn on, and whenever B0 becomes low, LED will turn off. And then this ground pin I will connect to ground over here, and I will change the value of this resistance. I will click here and click on properties. So the resistance is 100. I will change it to 330. This is the resistor I am going to connect, 330 ohms. And then the microcontroller. My microcontroller clock frequency is 8 megahertz. So here it's showing 16 megahertz. I will change it to 8. Okay. Now I am done. So next thing what I need to do is I need to write the code, and then I need to right click on this microcontroller and click on load firmware. Right now I am not going to load anything. I will load a firmware here, and then we will see this LED blinking. So that's all I want to talk about in this video. I will continue the discussion in the next video. The next video we are going to be writing some actual code for this microcontroller.